Today we're going to talk about piecewise functions. And piecewise functions it's a function, but it's made up of different functions over different parts of its domain. So in other words, it's a function in pieces. So piecewise defined function is a function made up of different functions on different parts of its domain. So we're going to do a couple examples of piecewise functions here. This is how piecewise functions are typically written as equations. So it says f of x equals, and then there's this fancy bracket that shows the different equations involved, the different functions. So x, if x is greater than or equal to 0. So in other words, this is the function x, the equation. X is greater than or equal to 0 is the domain of that portion of the function. And then negative x, if x is less than 0, so this is the domain, x is less than 0. Notice the domain is not written in interval notation, right? It's in inequality notation. So if we're going to sketch a piecewise function, the first thing we're going to do is kind of look at where the domain is and put that function in. Okay, so for this one, the function is x if x is greater than or equal to 0. So for that part, I will do some pink. So if x is greater than or equal to 0, let's start here at 0, 0. And we're putting in 0 for x, and we get 0 for y. So you could do this in a table. Okay, so if we're doing the function x, this is x, the y is y equals x. Okay. So if we can put in 0, and it says greater than or equal to. So we need to put in 0 and above. So we could put in 0, we could put in 1, we could put in 2, anything greater than 0. If we put in 0, we get 0. If we put in 1, we get 1. If we put in 2, we get 2, etc. So we'll try to graph that and notice that it's going to be a straight line heading out from the origin. Okay. For the second piece of the graph, it says negative x if x is less than 0. So for that part, if we're going to make a table, it's going to be x here, and then the y value will be negative x, or the opposite of x. Okay, it says if x is less than 0. We still do include that endpoint 0, which of course would be 0, 0. If we could graph it that way, it would be an open circle there. Okay, then we want to go x less than 0. So let's do negative 1 and let's do negative 2. When we put in negative 1, that's a negative, negative 1. Two negative signs make a positive. Same for negative 2 becomes 2. So when we graph that, we have, we start at 0, 0. There's already a point filled in there, so we're good there. And then negative 1, comma 1, negative 2, comma 2, etc. is going to go up like this. So when we make a straight line right there. Okay, so in other words, the absolute value graph, this is y equals the absolute value of x. The absolute value graph is a piecewise function. It is made up of two lines over a certain domain. All right, let's look at another. Okay, for our first piece, we have f of x equals x squared if x is less than 0, and then we have 1/2 x minus 4 if x is greater than or equal to 0. Okay, so the split in the domain is at 0 again. You'll notice once we get to the next one, it doesn't have to be, but it can be. So our first piece, I'm going to write this one in pink. Let's do a table. It's x is less than 0. So this is x. This is y equals x squared. That's this first function. And it says x is less than 0. Always put the endpoint, any of the endpoints of the domain in. So that would be 0, 0. And then we need to go less than 0. So let's put in -1. If we put in -1, we square that, we get +1. Let's put in -2. -2 squared gives us 4. And if we want to put in another point, we could put in -3. When we square that, we get 9. So that graph is going to look like this. So it's a parabola, it's just the basic parabola, which we probably should know what that looks like. So that's an open circle there at 0, 0. And then we have a point at -1, 1, a point at -2, 4, and then a point at -3, 9 there. So make that a nice little parabola there, a curve. All right. The second part of our function, let's do that in this blue again. So this says 1/2 x minus 4. So x, and the y value will be y equals 1/2 x minus 4. That's a linear equation. That's going to be a line, y equals mx plus b. And that's fine. And that is if x is greater than or equal to 0. So we have to put in 0. This time when we put in 0, 1/2 times 0 is 0 minus 4. So that's 0, -4. Then we could put in 1. I don't really want to because I'm going to get a half minus 4. So, -3.5. So maybe I'll put in 2. Okay, just so I have an easier point to plot. So 2 times a half is 1, minus 4 gives us -3. And let's do another one. Let's do another even number so we get whole number answers, just for ease. So 1/2 times 4 is 2. 2 minus 4 is -2. Okay, let's graph those points. So our first point is at 0, -4. And that point is filled in, and that's because it says greater than or equal to. Okay, so only one of those points on the same vertical line could be filled in, right? Vertical line test for functions. Okay, now go to 2, -3, and then 4, -2, and then you can, woo! Draw a straight line there. Okay, so this piecewise function, you can see it's in 2 pieces. The pieces are different than each other, but you have 2 pieces on 2 different domains. All right, let's do one more here, and then we'll do a different video. All right, so this time we have f of x being 6, the number 6, if -5 is less than x is less than -1. Okay, so let's make a chart for that. So x and then y is just always equal to 6. Okay, so what we're always going to do is start where the domain, just do the endpoints of the domain. So we want to have -5 in our chart, and then we're also going to want to have -1 in our chart. We don't necessarily need other points in our chart if we know what it looks like. So if we put in -5, well, y is always 6. Doesn't actually matter what x is. If we put in -1, same thing, y is 6. Okay, in other words, this is a horizontal line, right? That 6 is a constant. So this graph, notice that we have less than, so that's going to be open circles. So to plot those 2 points, that's -5 and then 6. I'm regretting making this paper so tiny. All right, there. And then we have the point -1, 6 right there. And remember, open circles. And then everything in between is that constant, that horizontal line. So that is the first piece in our function. That's this function. And the second piece in blue says x cubed if x is greater than or equal to -1. So let's plot that. So we have x, and then this is y equals x cubed. The point that we want to start with is when x is equal to -1 from the domain. So -1 and then cube -1, you're still going to get -1. Okay, and then we have to go greater than that. So let's go 0. 0 cubed is 0. We could go with 1. 1 cubed is 1. If you want more points, you could go with 2. 2 cubed is 8. Okay, just to get a good graph of it. So first point is -1 comma -1. Okay, remember that that was going to be filled in because of greater than or equal to. Then we have 0, 0, 1, 1, 2, 8. Okay, this is part of a cubic, right? If the cubic was just unrestricted, it would go down here, right? But remember that the domain only started at -1, so that's the first point that we would plot. Okay, so here again is a piecewise function with two pieces that are not continuous. They do not connect to each other.